So we have to think about things. So what we're going to do is, because this is a vector problem, we are going to do an analysis where it is a zero resultant, which also means it's a Newton's first law, right? It's at rest. So we can look at the x direction of everything that's going on. Well, if we look at the x direction of everything going on, there's only two forces. And notice how I labeled those forces by it. Notice those labels of those components, right? I have the force tension be x component, force tension be y component. Yeah, it gets awkward, right? Force tension A x component, force tension A y component. Yeah, it's getting bulky. They're getting bulky, and you can use other, abbreviations. I know some textbooks will just, make the tensions of just one letter. Some textbooks would just say, to shorten this up, instead of force tension, they'd be like tension by, right? So that T is going to take the place of the F. It reduces it by a letter, but you get the idea. Well, getting back to the x direction, x direction, you're in equilibrium. You're not moving, so those two forces must be balanced. They must equal but opposite each other. Yeah, must be equal but opposite to each other. Okay, but I don't know what those components are. I know they exist. Same thing goes with the y direction, right? In the y direction, I'm trying to get a good highlight color here. What's a good highlight color? We'll use gray. So in the y direction, I have that component, and of course I have the downward component. So I have the upward y components of each tension, and I got the downward weight. And they're going to add to zero, because again, you're not moving, and secondly, the vector quantity resultant's got to be zero. We don't want this to move. Well, what are we going to do with this? It doesn't look like we have enough information to solve, because we have all these unknowns. But we do have enough information. That's the wonderful and the pain about these problems. And so what we can do is do this. You're like, what is that? Well, let me take you through it. I'll take it through line by line. At least mostly line by line. And so this is the fun times. So this first set of lines, by the way, this is the most important set of lines right here. That basically maps out where you're going to go. Like, we know that the components of the x got to equal 0. We know all the components of the y got to equal 0. So that is the basic statement. We had to build that from our diagram. We had to build that from our statements. And then we can go and break this down even further. But we have to realize, hey, this, nope, didn't want to do that. This x component, well, isn't that equal to the cosine times the angle with the hypotenuse involved? Right? Like, here's the x component. Well, if I know the x component, and I know the hypotenuse, and I know the angle, well, isn't that cosine? Actually, I just highlighted the wrong one, didn't I? Because I was talking about A. All right, but still, if I know the x component, or I'm looking for the x component, I'm looking for, or I have information, I'm looking for the overall tension, and I know the angle, well, adjacent over hypotenuse, that's cosine. Right? And again, we did the same thing. I already highlighted it earlier, just incorrectly. We know that we're looking for the x component. We're interested in the hypotenuse. We know the angle, so I can make that a cosine statement. And that doesn't look like it helps us that much, but again, with these problems, you're scraping to solve, with anything available that you have. Now, of course, that same kind of logic can go into the y direction, right? So instead of FTAY, well, that's this. Again, I'm most interested in the hypotenuse. I'm looking for that overall tension, and I know the angle. Well, that's opposite over hypotenuse. That's sine. Same thing here. So I can substitute those components with the trig functions that are associated with the hypotenuse or the overall tension. So that's fun. Not really, but that's what we're going to do. And of course, lastly, mg, we knew that the hanging mass, that downward force was that hanging mass, so that weight. So that's just m times g. And now, once we have that, note the following. We know everything except for the overall tensions. And there's two of them. We do know M and G. I gave you that. I told you it's 10.2 kilograms and 9.8. So we only have two unknowns. And we have two equations. And so we're going to solve that. And so that's what the remainder of I have below is going to show us. And so there's just a math game at this point. That's all the math right there. Check it out. So let me move it all up and let me talk you through it. And I'll bring it down and go through it kind of line by line. So what we can do, of course, is substitute in the values for sine and cosine here. I happen to know that, cosine and sine of 45 degrees is root 2 over 2. You should know that from trig or geometry class or trig class. And I happen to know that 36.9 degrees gives me the fractions 3/5 and 4/5 because it's a 3-4-5 triangle. Also 3/4 or 4/3 for it depends for tangent, but I'm not dealing with tangent right now. But you can plug those in your calculator and get decimal answers if you do sine of 45 or sine of 36.9 or cosine or whatever. And I do know, again, I know 10.2 and 9.8. I know those. And like I said, if you did not know the fractions, you could literally just plug in cosine or sine into your calculator and get those decimal values. And yeah, it looks messy. It looks messy. Sure, it looks messy. But that's okay. The point is, again, you just have two unknowns. The tension of A and the tension of B. We're looking for both of those. So if I have two equations and two unknowns, I should be able to solve. And what you can... didn't want to do that. What you can do, of course, is, it looked like earlier, you were stuck. But you're not stuck because you can substitute in from x. How did I know that? Well, because if I looked and finished up all this x stuff, and plugged it in, right, I can rearrange it, and I can even put one term in terms of the other. I could put TA in terms of TB, FTA in terms of FTB, and I can get that number. And then I can sub in for one of the variables. And that's what I do. I take this, and I take that FTA being equal to 1.13 FTB, and I substitute that in right here. And once you do that, you can solve for FTB, which I do. And then once you do that and get that value, you can sub back into the previous equation and get FTA. And that's what I did. And so that's again another case where, you know, this theme of knowing information one direction, not having, wow, tapper talk. The whole concept of having two unknowns, but having two equations and having to solve them, you know, by substitution or simultaneous or whatever, but there's different methods to do it. But what that does is allows us to find those tensions in those wires and make it work out. Now, this is a pretty straightforward example. I'm going to give you a bunch of others. I'll give you, I think, at least 2 more to try over the weekend. Okay? So, try setting those up and come to the next class with